I welcome you to today's class, and in today's class we are going to be looking at the International System of Units. By the end of this class, we should achieve two important things. Number one, we should study the SI base units and the SI derived units of given physical quantities. We should explain the advantages of the SI system of units, and we close our class. Now, let's quickly dive into the first objective. The International System of Units is also known as the SI. In most cases, I'll be using the term SI units, SI units. I'm referring to the International System of Units. And it consists of two types of units. Number one, we have what we call the SI base units, which are coming from the base quantities we discussed in our introductory class. It also has, number two, what we call SI derived units, which are obtained through multiplication and division, as we discussed concerning derived quantities last time around. Now, let's look at the SI base units. What are they? SI base units are the 7 fundamental units of measurements that are not defined in terms of other units. We defined the last time base quantities, and we said there are 7 fundamental quantities which are not defined in terms of other physical quantities. Now, their units or their corresponding units are what we call the base units. So we say they are the 7 fundamental units which are not defined in terms of other units. Now, if we recall the 7 fundamental units, we had the 7 fundamental quantities: mass, time, length, temperature, electric current, amount of substance, and luminous intensity. These are the 7 fundamental quantities. And their corresponding units are what we call base units. Now, I want you to see this. Every physical quantity has its own symbol. For instance, instead of writing mass is equal to 50 kilograms in words, I can just safely say M is equals to 50 kilograms. I use the M as a symbol for mass. Now, when you're using a symbol, it's very important to take note of the case. You might have one letter which takes a different meaning if it takes a different case. For instance, we have time, which is represented by small letter t. We have temperature, which is represented by capital letter T. So the moment you use capital letter T in your equation, you're talking about temperature. The moment you use small letter t, you're talking about time. So if you write t is equals to 50 seconds, there is a problem here, because this is a symbol for temperature, not time. So be very sensitive to the case you use. Now, for each physical quantity, there is a symbol representing the physical quantity. But I want to dwell on 3 important physical quantities which are new at this level of your IGCSE. Now, the first thing I want to talk about is luminous intensity, which talks about the amount of light, the quantity of light. It has a symbol L subscript V. Please take note, it's not LV. This V is a subscript. So it's L subscript V, and the unit is a candela with a symbol CD. We also have amount of substance. So you can say the amount of substance N is 2 moles. The symbol for amount of substance is N, and amount of substance is measured in moles. Now the symbol for moles is MOL, a mole. Just remove E from the name. Now, I also want to talk about temperature because my students, in most cases, they are used, especially here in Zambia, they're used to using degrees Celsius. So they normally think the SI unit of temperature is degrees Celsius. You might have the same if in your country you're using Fahrenheit. The SI unit of temperature is a Kelvin with a symbol capital K. The SI unit of temperature is a Kelvin with a symbol capital K. I think you are used to mass, you are used to time, you are used to kilograms. You can read this and as you go through the video during your own time. Now let's talk about SI derived units. What are they? These are units of measurements derived from base units of the component base through multiplication, division, or both. Just like derived quantities are obtained from base quantities through multiplication, division, or both, like we discussed in the last class. Derived units are also obtained through multiplication, division, or both. What are we multiplying? What are we dividing? Base units. Now, let me use some examples here. Now, we know that volume is three-dimensional. In most cases, I'll use a cube, which is LBH. In a cylinder, it's pi r squared for this area of the surface at the base times the height or the length of the cylinder. It's three-dimensional. Now, in that case, if we want to derive the SI units of volume, we are saying volume is the same as length times length times length. Volume is the same as length times length times length. Why are we saying so? Length is just the distance between 2 points. Width, the B over there, is also the distance between 2 points. From this point to that point, that's the width. Just that we are going in another plane. Then height is the distance also between 2 points, but in the vertical plane. So this is length, B is length, height is length. So at the end of the day, the SI derived unit of volume is the unit of length times the unit of length times the unit of length. What is the unit of length? From the previous table, it is a meter times another length, a meter, times another length, a meter, giving us a cubic meter. So with the SI unit, we end up deriving the units of derived quantities from their base components. Now, we say density is mass over volume. I'm now dealing with the density. So the units of density should be equivalent to the units of mass divided by the units of volume. What are the units of mass? Kilograms. Mass is a base quantity, and we said it's measured in kilograms from the previous table. And what are the units of volume? We have done volume here, and we said it's a cubic meter. So we can safely say the units of density are kilograms per cubic meter. How are we reaching to this point? We are using multiplication, division, or both. So derived units are units of measurement derived from base units of the component base through multiplication, division, or both. Let me do the last example, which is speed. The symbol for speed is V, which is calculated as distance divided by time. So what are the derived base units of speed? The units of speed must be equivalent to the units of distance divided by the units of time. What are the units of distance? Distance is length. We said they are meters per for this division line here. What are the SI units of time? From the previous table, we said they are seconds. So we can safely say the derived base units of speed are meters per second. Okay, now let's take a break, and when we come back, we'll look at the second objective. What are the advantages of the SI system of units? Right, you are welcome. Let's deal with the international system of units. What are the advantages of international system of units? It is very important. It's recognized like the name internationally because of three main reasons. Number one, the international system of units is a rational system. What do we mean by it's a rational system? It is a system in which only one unit is assigned to one physical quantity. The SI unit of temperature is a Kelvin. No matter how much you love degrees Celsius because you use them oftenly in your country, they will never be SI. The SI will remain a Kelvin. The SI unit of temperature is a Kelvin. So for every physical quantity, there is one unit assigned to it. So if all base quantities have one SI unit assigned to it, that creates uniformity. Whether you learn physics here in Zambia, you learn physics in the UK, you learn physics in the United States, you learn physics in Asia, you learn physics in any other continent, South America, America, whatsoever, you still have a uniform unit for temperature. We still have the uniform unit for mass. We still have the uniform unit for time. You might be using minutes or hours or days prominently in your country. But when we come to science conversions, we'll still say the SI unit of time is a second. So that creates uniformity. One unit assigned to each physical quantity. Number two, it creates coherent. It is a coherent system. What do we mean by it is a coherent system? We are saying we can obtain derived units from their base quantities. Like we discovered that the SI units of density are kilograms per cubic meter. Why? We divided the units of mass by the units of volume to come up with the units. So every other derived unit or supplementary unit can be derived from the definition or the equation involved with the physical quantity of which is derived. So it is a coherent system. We should understand the meaning of coherent system. All derived units can be obtained from their base component. The last thing which makes the SI system of units very important is that it is a metric system. What is the meaning of the term metric system? What do we mean by metric system? It means the multiples and submultiples can be expressed as a power of 10 for easy conversions. For instance, we have 1 million kilograms. You can see it's quite a long number. We can safely say this is the same as 10 to the power 6. So it's very important to note that it is a metric system. Multiples can be expressed to the power of 10 for easy conversions. Today's class ends here, and in the next class we'll talk about conversion of units, looking at the metric property of the SI system of units. Chigo, the senior coach, signing out. Enjoy your day.